All right. My name is Chris Goodson. I'm a senior ecology section manager with the Georgia Department of Transportation. I'm going to try to fly through my stuff so we can get to the real star of the show, which is Kimberly, who did all this research. But first, a little bit about Diamondback Terrapins. For those who may not be familiar, they're all the way up and down our eastern seaboard, and they primarily are living in salt marshes in those brackish habitats. An issue in Georgia, we have a lot of barrier islands, which means a lot of causeways, and that creates great nesting habitat for diamondback terrapins. They're looking for the highest, driest land they can find to lay their nests, and they're coming up on the roads, oftentimes crest in the middle, trying to find that highest spot and getting hit by vehicles. So connectivity is not really the concern in this particular case. It's a case study on the Tybee Island Causeway. Because we've got bridges on either end that they can cross, it's really about coming up for nesting. And it's really just during a certain time of the season. So it just gives us a target of where we need to apply potential minimization measure, and really around that high diurnal high tide on 3 hours either side of that. So we as a DOT needed to be able to exclude those animals from the roadway, but we also didn't want to lose nesting habitat, which is really critical for that species survival. So we were looking for a solution and looking for a specific barrier that would meet our needs. There's three main projects that I mentioned. There's the causeway in the middle, but then there's a bridge on either end, and we're advancing those bridge projects right now, which is good because those are a couple of the hotspots that were identified. We had a lot of research that had been done by the Tybee Island Marine Science Center, and so we knew where some of the hotspots were, and it's really a data set that I think is over 10 years old. There are some maintenance considerations, though. Tybee Island Causeway is very low lying, and so it floods frequently. And that when you get rack from the marsh and everything up on the roads, if you had any traditional fence type, then you've got all that rack that's trapped now inside the right of way. And that was a major maintenance concern. And so they really didn't want to do that when we talked to our district office, who would be doing that maintenance, which led us to try to create another solution. I mentioned the bridges, and so we thought, hey, could we just attach something to the guardrail? That could be great. And we talked to our design policy folks, and they said, you really can't do that because it hasn't been tested, but you can put something 4 feet behind it. And so we started looking for barriers that we could put behind it that would not have those maintenance concerns, that would give us those clear zone or meet those clear zone requirements that we had. And we also wanted to look at some other mitigation measures. So we talked about signage. There were some kind of static signs out there, and I think we've seen research that says that those are not super effective. Some other places they've done things where it only lights up during, they have lights and they only light up during certain times. But actually, a few years ago on the Tybee Island Causeway, we installed these changeable message signs. And so during that nesting season, on a couple hours either side of that diurnal high tide, a message flashes that says, hey, turtles are on the roadway. And also, please leave space between vehicles, because leaving space is often not the first person that's going to hit the turtle. It's going to be the one right after that. But I talked about wanting to preserve some of that nesting habitat. With these bridge replacements, it's the only way on and off of the island. You can't really shut down the road. There's no alternative means to get out there. So we're going to be replacing those bridges adjacent to the existing bridges. That's new fill within the salt marsh, but it does leave us an opportunity as we take the fill out of the from the other bridge to use that, grade it, and have nesting habitat that turns into a great mitigation opportunity to actually increase the overall nesting habitat on these projects. So that's something we're currently building into our design. And you can kind of see that additional area highlighted here that would then just turn into dedicated terrapin nesting habitat. Exactly how we do that, well, maybe that's the next research project. So this would be the typical section, and I realize that's probably hard to see, but it just has that 8-inch curve is what we initially thought might be a good height to limit terrapins, but that was really just a guess. We didn't know. We looked out to see if there anything else had been done. It was a reverse curb idea so that things could flow off the roadway, all that rack doesn't get trapped, but it would keep terrapins from climbing up onto the roadway. So we needed to put that to the test. And I think that's where I'm bringing you up, Kimberly. And so Kimberly is going to come up and she's going to talk about how we went through that research and some different curb designs that we tested. And by we, I mean her.
Hey, everybody. This was a fun project and a unique opportunity to actually test a design before it was put into place. I'm hoping that that becomes less and less of a unique approach. Chris and I worked together on some ideas. Some of this was pulling from the literature and some other designs from other places that you may recognize, but we were testing a 90 degree with an inward lip that was 3 inches, and then a 70-degree reverse angle curve. And you can see the sections here. We captured 118 terrapins, and we used road cruising. We did pedestrian captures, walking some of the trails around Fort Pulaski. We biked, we seined, and the general gist of this was that we wanted to catch these animals, run them through the experiment, and then have them back in the marsh and released within an hour. This is particularly important because we were capturing gravid females, since they're primarily the ones that are crawling up. We got 118 terrapins overall. So we had 2 designations, trespass, meaning they successfully climbed over the wall, versus no trespass, where they were not able to get over the wall. We did have 2 considerations for if they trespassed, but that it was assisted. So we had an additional treatment where we added 1 inch of rack. If they tried 3 times to get over and were not successful, we then added the 1 inch of rack. Keep in mind that in the real world, when we get rack wash up during some of these really high tides, it's far more than 1 inch. But we wanted to incorporate this. Also, terrapins are incredible climbers. They're adapted to climbing over oysters and the high marsh, and so we wanted to note if they were able to use the poly wall that we ended up adding to simulate an angled fence that's going to come off of these curbs. And then we randomized the order in which the different curbs and heights were tested. Okay, so these are some examples of the video. I'm super excited that they're working so far. This is an example of a terrapin crawling over unassisted on the 6 inch. They had no problem with this. This is an example of a terrapin crawling over the lip that had some of the rack. And then this last example is a terrapin unsuccessfully climbing or trying to climb over the angle. And I will say that terrapins can readily flip themselves over. We did not have any animals that were harmed during this. And I also want to emphasize this was a test of physiology. We had a very basic runway design, and we were wanting to look at physically what could they climb over, and not trying to simulate real world behavior. We did have all of these curbs were facing the marsh. So in some, we looked at how many attempted to climb over, because as you appreciate well, that there's an energetic component there. So with the 90, we had a lot of animals attempting to get over. With the 90 with the lip, we have fewer attempting. One of the issues with the shorter heights is that they would just go sit under the lip, and on the 6 inch, it was actually problematic for the females because they were tall enough that it was a problem to wedge themselves under. The 70-degree angle, we simply had fewer animals, especially at the larger or the higher heights that were even trying to climb the fence. So then these, I'm going to give you breakdowns specific to each one of the curb types. And again, no rocket science here. You can see that the 12-inch curb was the most successful, and we had quite a bit of trespass on the 6 and 8 inch. Again, just a straight 90 degree. The 90 degree with a lip, we had considerable fewer instances of trespass, and we saw high degrees of success with 10 and 12 inch lips. And then lastly, with this 70 degree reverse angle, we saw the greatest success with this one. And I will say that 12 inch was an animal that used the wall to climb over. So these are just those same graphs that I just showed you side by side for a visual comparison. And then Chris and I also put this graph together because we wanted to look at where they had assisted trespass. Were they using the rack versus the wall? So this was part of our internal presentation back to Georgia Department of Transportation, because these are two different issues to think about, right? If it's a wall trespass, that's a design factor, and using things like curving rather than 90 degrees or hard angles coming off can assist that, versus rack, which is a conversation we need to be having with the maintenance department of how frequently do we need to keep these rack areas clear. So in summary, we broke this down. Our recommendations were based on the likelihood of trespass relative to the maintenance burden. And so some of these conversations are ongoing. There's actually a patent process. We conducted the experiments through UGA, and just wanting to make sure that Georgia Department of Transportation has the rights to use any of these curbs. Ultimately, our recommendations were for a higher curb and that 70 degree inward facing angle. I wanted to thank GDOT for funding and co-design. Chris Goodson deserves a lot of accolades for this internally. He was really an advocate for the power of doing research and science-based designs. And so aside from the results here, this is something that I hope sets a precedent that we can continue to follow. District 5 maintenance cast these curbs. There were some pretty interesting conversations when we were talking with them specifically about what we needed, but they're fantastic. National Park Service at Fort Pulaski hosted one of the sites. We had a second one in Brunswick. And Chris mentioned the valuable mortality data we had from the Marine Science Center. And then thanks to my lab, who spent a lot of time trying to catch these animals. And if we have time, we'll happily take questions. Yes, there is a technical report, and that's on the Georgia Department of Transportation site. And then as we get through the remainder of the process, Chris and I will be working on a publication that we can submit to a journal.
And you should be able to just Google GDOT library, and that's where most of our research is. And this is the only turtle research we funded so far.
Things that you started with, like, sort of the height of the wall, or experience cost, and looking
I'll start, and then I'll hand it to Kimberly. In talking to our design policy folks, it is the only reason that we're able to get away with such a drop off at all was because of the guardrail. As we get onto the causeway, that's going to present a new challenge, because if you have a big drop off, it's not necessarily about the car dropping off. What they're worried about, especially in this area, is a small right of way. It's cars dropping off, overcorrecting, coming back, and going into oncoming travel lanes. And so our approach here on the bridges is going to be something that may be different as we get to the causeway.
And then in terms of, well, naturally, it's more expensive to produce the larger curbs, but that's a production cost. And ultimately, the higher curbs, if they don't require as much maintenance, are going to be an overall cost savings to Department of Transportation.
So, like a shorter purpose that higher than this house.
Sure, so the question was about the higher or the shorter curves having higher maintenance cost. Sometimes we get so much rack that with those 6-inch curves, they could actually completely be at level. We also talked a lot about which would be easier to clean off. So interesting conversations with maintenance. It was really fun talking with the different departments, but the lip having a square device, maybe that they could have something that they adapted to push the rack through, and the angle being a little more complicated for maintenance, but the maintenance department's original recommendations were that shouldn't be such a substantial difference that it would be the main determinant. Anything after that?
Yeah, and I think it just depends on the elevation of your causeway. This one happens to be, I don't know, something like 7 feet above sea level, so it's like very, very low. Whereas a higher causeway, you might get away with a shorter wall because you're not going to have that rack constantly washing up on it.
So I'm not a resident of this, I want to say thank you to you for the set, because it's so interesting you both are up across these. Looking at the nuances of like heights and shapes, like message, for example, I think it's like seldom done. There's typically was a historical recommendation for certain hosts, certain materials, which we look at everything, you really need, and we have our friends, certainly, it's getting on guidelines and not things that you are seeing, still that effectively, as what we sort of showed, too hard, so it's great seeing.
Yeah, thank you. And part of that is because we border the National Park Service, so they're very worried about the view shed from the park. And so we definitely have been working hand in hand with them to come up with a solution that they feel like is not visually distracting from the environment and their park.
I was just going to add to that real quick. Some of that is also an education piece of, yes, the fence may affect the view shed, but I think we should consider that dead turtles all over the road also takes away from the view shed.
800 because Terrapin hotspot areas, problem areas for to and it's the material of the 3 designs. 2 questions. What's the material that we're getting from? And I was wondering if you had any experience with erosion control taking. Not that it's going to work necessarily with the flooding, but just experience with erosion to deter the barrier.
Yeah, the material that we're proposing using is just a concrete curb, and with every curb, you can also have different finishes on it, all concrete. So we are talking about having that be a smoother surface where terrapins, who are great climbers, can't necessarily climb up nearly as easily. And then silt fence, I've heard, and maybe you can speak to this better, that they can climb right over the top of that.
Yeah, we originally had silt fence on our back of our testing area, but they would just turn around and literally scale that silt fence in about 15 seconds. And that's why we replaced it with a poly wall, because it was a smooth surface that they couldn't get their claws into. But it's an important consideration and part of the reason we're going for concrete, because as it degrades in these very hot, high salinity environments, and that's a big limitation for us not applying some of the things that are successful with terrapins in the Northeast. As those materials degrade, they can get their claws into it and they're going to be able to get over it. So we're looking at it maybe for temporary exclusion during construction, but for permanent structures on these causeways, personally, we're recommending the concrete materials.
And if anybody does have ideas about how to exclude them during construction, that would be great.
Thank you all. We're around the whole time.